Hod Lipson, Driverless, Intelligent Cars and the Road Ahead, MIT Press. Embark on a journey into the future of transportation as we explore the world of intelligent, autonomous vehicles in Driverless, Intelligent Cars and the Road Ahead. Author Hod Lipson delves into the transformative impact these advanced machines will have on society, from the potential for saved lives and decreased pollution to the loss of jobs in the transportation sector. Learn about the importance of artificial intelligence and robotics in the development of driverless cars, as well as the ethical and privacy considerations that come with this revolutionary technology. Discover the gradual and safe emergence of autonomous vehicles in the coming decades and how they will reshape the way we commute, work, and live.
The driverless future. The rise of autonomous vehicles will revolutionize transportation, save lives, and improve the environment. Though concerns of job loss, privacy, and ethical dilemmas will arise, the benefits outweigh the downsides. As deep learning software and robotics advance, driverless cars will become twice as safe as human-driven cars. Moreover, autonomous cars will rely heavily on data and sensing technologies to navigate through the complex social environs of drivers and pedestrians. It is believed that driverless cars will emerge gradually and safely over the next few decades. People will initially use them for freight, then as shuttles, and finally, as personal transport. For the first time, cars will become the first mainstream autonomous robots that we entrust with our lives, and this disruptive shift will impact everyone. The pros and cons of driverless cars. With the advent of driverless cars, we are poised to enter a new era of transportation that promises greater convenience and less pollution. However, there are also some concerns about the potential for increased congestion and wear and tear on vehicles. Moreover, the automotive industry lacks experience in robotic operating systems and seeks gradual shifts to autonomous driving that maintain profitability and limit liability. Current autonomous systems lack integrated intelligence, and the U.S. Department of Transportation, DOT, favors a gradual shift into driver assist and limited autonomy. Despite these challenges, the benefits of driverless cars are clear. They cut the need for parking lots, freeing up space for urban improvements, and cheap, easy personal commutes would bring people a greater choice of jobs and lifestyle. With Google, Apple, Mercedes-Benz, Toyota, and Volkswagen investing heavily in car autonomy R&D, federal transportation officials have the resources and legislative muscle to throw their support behind driverless cars and save tens of thousands of lives each year. Driverless car operating systems. The quest for reliability and safety. With the rise of driverless cars, the operating system, OS, must meet high-level controls that plan and navigate, as well as low-level feedback that regulates systems. The vehicle's safety relies on the system's speed, reliability, security, and redundancy and involves expertise from university robotics departments, such as Carnegie Mellon University's National Robotics Engineering Center. Researchers face challenges, including Moravec's paradox and artificial perception requiring machine learning. Federal regulators may require a human-safe rating to double an average human driver's distance before an accident. The rise and fall of the electronic highway. The 1956 Federal Highway Act and the Interstate Highway System jump-started the car culture in America. General Motors and RCA proposed a futuristic electronic highway using buried cables and in-car sensors for feedback control, but the idea failed due to high costs. Carmakers shifted focus to consumer safety issues, and the rise of fuel prices and traffic congestion stalled out futuristic visions. However, with the cost of equipping an autonomous vehicle dropping rapidly, outdated paradigms like vehicle-to-vehicle and vehicle-to-infrastructure systems for data exchange are being replaced by cheaper Internet of Things technology on standard roads. Federal regulations could enforce safety standards, define liabilities, and protect privacy in the rise of autonomous vehicles. As of 2015, Nevada, California, Florida, and Michigan had autonomous vehicle driver's license schemes in place. From military to mainstream, the evolution of driverless technology. The robotics revolution fueled the development of modern driverless technology starting from the military demand. The origin of pattern recognition techniques can be traced back to the computer gaming, board games, and the IBM-based checkers game. The technological senses of autonomous vehicles rely on high-definition digital maps, digital cameras, spinning LiDAR devices, and sensors like radar and sonar. The combination of merged technologies such as big data, GPS, miniature components, and digital cameras makes exponential progress in driverless technology. The convergence of electric cars, ubiquitous wireless, car-sharing and autonomous vehicles is forcing car companies to rethink their business models, and autonomous vehicles are becoming the next big consumer device. Driverless cars and the power of deep learning. Driverless cars rely on deep learning neural networks to create HD maps, which are updated and improved through fleet learning. By pooling their experiences, these cars can plan journeys in detail, making them as efficient as an experienced human driver. However, there are ethical concerns surrounding emergency situations and potential privacy infringement. With future HD maps having great advertising potential, questions arise about the limits of AI's marketing capabilities. Driving into the future. The driverless car industry holds the potential to revolutionize the way we travel. With the aim to reduce harm, required driving skills, and time spent driving, the industry designs vehicles that are both smaller and more luxurious. However, the shift to automation may also result in income inequality, as many professionals, such as truckers and driving instructors, lose work. The evolution of driverless technology is part of a larger trend in robotics, where exponential improvements in technology enable batteries, sensors, data storage, processing power and algorithms to perform parallel functions in robotics and AI. Some experts predict that self-improving algorithms may lead to AI self-awareness, making the idea of a driverless car that enjoys its work not entirely far-fetched. However, with any new technology comes new risks, as the threat of driverless hacking and robojacking looms on the horizon.
As the curtain falls on the incredible journey through driverless, intelligent cars and the road ahead, it's clear that the advent of these autonomous machines heralds a significant shift in our lives. As technology continues to advance, the benefits of driverless cars will become increasingly apparent, offering safer transportation, improved mobility, and reduced environmental impact. However, it's crucial to acknowledge the challenges that lie ahead, including the loss of jobs and the need to manage ethical and privacy concerns. The exciting future of driverless cars awaits, promising to reshape not only our daily commutes but also the very fabric of our society.